There are three specific special series that you're going to need to be familiar with. I'm going to build them fairly quickly, but I'm also going to show you the interval of convergence to make sure you understand where that comes from as well. So the first one that we're going to talk about is e to the x. Now these are Maclaurin, so that means that the center is at 0. We're going to start with f of x is equal to e to the x. So the derivative is always going to be e to the x, which is nice. That's going to limit some of my potential for error there for sure. At x equals 0, e to the 0 is always going to be 1. So these values that I'm following are always 1, and now I just have to tack on that Taylor term, right? That x squared over 2 factorial, etc. So I want to make sure that I continue here. So when I get to this last term, my general term, remember technically we were multiplying this by x to the 0, but we didn't have to have that. Then we multiplied this one by x, and then this one was x squared over 2 factorial. The reason why I don't have a center is because the center is at 0, right? So it was an x minus 0 squared. Hopefully y'all remember that. So my nth term is going to look like x to the n over n factorial. That is the series, but I want to show you that the interval of convergence is everywhere. It doesn't have a finite interval of convergence. This is going to be true always. For no matter what the x is, e to the x is going to equate to this series. So let's do that using the ratio test. So we're going to say the limit as n approaches infinity. Remember, you have to add 1. So x over n plus 1 factorial. Get my absolute value signs around there. And then over x to the n over n factorial. Now multiply by the reciprocal, so it's a little bit easier to look at. So you have x to the n plus 1 times n factorial over x to the n times n plus 1 factorial. So now you have an extra x. When you subtract these, the x is left. When you simplify the factorials, you end up with an n plus 1 on the bottom. So the x I can factor out, and the limit as n approaches infinity of 1 over n plus 1 is going to be 0. So you're dealing with the absolute value times 0, which is of course 0. But with the ratio test, you want it to be less than 1. That's always less than 1. So the interval of convergence for this is everywhere, right? It's negative infinity to infinity. So that's what the question is asking. For what values of x does e to the x equal this series? For all of them. So e to the x is the same as 1 plus x squared over 2 factorial plus x cubed over 3 factorial. Then we're going to keep going, and then we're going to say x to the n over n factorial. That's that general term. So these are equivalent to one another, and they're equivalent to one another no matter what x is.